Okay, let's look at all the rules and all the other functions. So we've done polynomials, but all these other functions. So let's start with y equals sine x. Now remember, if we want to find the derivative gives us the gradient of the tangent. So at this point here, the tangent is 0. At this point, the tangent is 0. At this point, the tangent is 0. And at this point, the tangent is 0. And at this point, it looks like the tangent is basically 1. The gradient of the tangent is 1. And back here, it is maybe minus 1. And here it is 1 again. So what you have is that the sine curve, its derivative, is going to look something like this. And it just keeps oscillating between like one oscillation or one wave behind the other one. So what you have is the derivative of sine x is just, or y dash of sine x is just cos x. And that's one of the rules. And in a very similar way, the derivative of what, if we have y equals cos x, then to y dx is going to equal, or the derivative is minus sine x. That's another one of those rules. If we have, and we could use the chain rule, but we haven't got to that yet. If we have y equals sine 6x, then we just find the derivative of this, which is 6, and we're looking for y dash. The derivative of this is 6, so it's 6 cos 6x. And the same happens for the cos curve. So there's our first rule. What happens to sine? It becomes cos. What happens to cos? It becomes minus sine. The other functions that we're going to have to deal with is y equals e to the x. If we want to find the derivative of that, to y dx of e to the x is just e to the x. And that's the beauty of why we picked this number e. 10 to the x isn't 10 to the x, but e to the x is. And again, that is our rule. If it is a power like this, y equals e to the power of 3x squared plus 2, then our derivative, y dash or y prime, we take the derivative of the top bit, 6x. 2 times 3 is 6, then drop the power by 1. The 2 just becomes 0, so we get 6x e to the 3x squared plus 2. And again, we're going to look at the chain rule, and the chain rule will help us with that one too, just to show that it is. But they're nice, simple rules. Log, when we're dealing with logs, it's almost the opposite to exponentials. We've got y equals log 3x here. So how do we do that? We find the derivative of this, which is just 3. So to y dx equals the derivative of that equals 3 over that 3x. If it's something, and we could simplify that, but if it's something like this, we find the derivative of this term in here. So y prime is going to be, the derivative of this is 2x over x squared plus 7. And that's all when we're finding the derivative. So they're the rules that we have to deal with. We have to know what sine becomes, what cos becomes, how to deal with exponentials, and how to deal with logs. So let's look at the product rule. This is where it starts getting a bit more difficult because we've got lots of things happening. Now the product rule, I like to write it as the derivative of uv equals vu dash plus uv dash. So in other words, if this is our u and this is our v, the derivative y dash is going to be v sine x times the derivative of u. What's the derivative of x squared? 2x plus u, which is x squared, times the derivative of v. What's the derivative of sine x? That was one of the things we had to remember. Sine x becomes cos x. And that's all the derivative is. Now, it looks difficult, and we probably should write this so we don't get it mixed up. This becomes 2x sine x plus x squared cos x. Okay. If we had a different product rule, maybe f of x equals x cubed e to the x squared. Again, this is our u, this is our v. Our formula is the derivative of uv equals vu dash plus uv dash. And it's just nice. It's nice in that sense that it's uv is vu dash plus uv dash. And I'll just put the dash so you can see it. There. Okay. Oops. Okay. So in this case, what is v? V is just the e to the power of x squared, e to the x squared, times the derivative of our first one, which is 3x squared. And this is going to be f dash. I've changed the notation. It doesn't change anything, though. It's still, this is the derivative. This is the derivative. So 3x squared e to the x squared plus our u, which is x cubed, times the derivative of our v. How do we do exponentials? We take the derivative of x squared, which is 2x e to the x squared. Then we write it again. The quotient rule. This is a quotient because we've got a quotient. The other one was a product rule because we had a product. So this is the quotient rule. Again, this is our u, this is our v. And we've got the derivative of u divided by v equals vu dash minus uv dash. We have to get the order right here, all over v squared. So again, they just swap uv, vu, uv, and the derivative is always at the back. So uv, so it's v is the bottom one. So we get x. What's the derivative of sine x? Cos x minus sine x. What's the derivative of x? 1. All over v squared, which is just x squared, because this is our v. So we want v squared in this case, so it's just x squared. And that's the quotient rule. And obviously they get quite complicated at times, but that would be what dy dx equals there. Okay, so again, lots of rules that we have to do. And the chain rule. Now, I'm going to go through this slowly because I think it's going to become more important when we do the next thing that we have to do, and being able to manipulate derivatives. Okay, so we're going to write this. I'm going to let's let u equal e to the 2x plus 1. Okay. So over here, I've let u equal the bracket. So what we've got now, we've got two equations really. We've got y equals sine of u, and u equals e to the 2x plus 1. Now over here, remember what we really want to find is we want to find dy dx. That's what we want to find. So here, we're going to find dy du because we've got y's and u's. So this is going to be dy du. So if this was sine x, it'd be cos x. Now that it's sine u, it just becomes cos u. Nothing hard about that. Here, we are going to get du dx. It's not going to be dy dx anymore. We've got a u here. So it's going to be du dx. So du dx equals, we bring the power down, 2 e to the 2x. And when we differentiate 1, it just becomes 0. Now, what we actually wanted, we wanted dy dx. This is why we call it the chain rule. So what we've got, we know that dy du is something, and we know that du dx is something. And if we multiply those two things together, that cancels out with that, and we've got dy dx. So what was dy du? Dy du was cos of u times, and what was du dx? Times, and let's put it in brackets, 2e to the 2x. And that's basically it, except the one thing we haven't got now, in our question, we didn't have a u. That was something we made up. So let's substitute that u back. What was u? So it's cos of e to the 2x plus 1 times 2e to the 2x.